Good evening, everyone. We'll get started here in a minute as everybody comes in from the waiting room. All right. Well, thank you everyone for coming out tonight and joining us for this webinar this evening. Real excited that um, we have two fantastic presenters, Drew and Dom from OnShape, who are going to share with you. I should back up and say we've been working with OnShape for, I think, the last 3 or 4 years, and um, they have been helping us on the competition side. And there's a new event we've been trying out for the last couple of years called Engineering CAD that they're going to actually talk to you about next month. But tonight, we got a number of questions in some previous webinars about, hey, how can I go about designing stuff, and how can I keep the costs down and have more opportunities when it comes to the build events? So we're talking about things like air trajectory, scrambler, electric vehicle, all the stuff where you're constructing things. And what's going to happen tonight is Drew and Dom are going to talk to you a little bit about how OnShape can kind of help you out in those situations. Just so everybody knows that this session is being recorded. We will get a copy of the webinar out to everyone that has registered as soon as it's ready. We'll also post it up on the Science Olympiad TV YouTube channel. Two last items of business. If you have questions, I'd ask that you put them in the Q&A feature. And depending upon how your screen's set up, you'll find that in the towards the right-hand side of the tray at the bottom. You should see Q&A. It's a little box with a question in it. Then the other thing is, should you need to communicate with us, you're having a sound problem or you want to make sure things are working, you can use the chat feature, and that's a little bit more towards the left-hand side. And you can go ahead and type in there and chat away. And I'd actually ask if you could please, in the chat, drop in what your role with Science Olympiad is. Are you a student? Are you a coach? Are you a parent? And two, along with that, tell us what division, because we'd really like to know that as well. But as you do that, without further ado, I'm going to turn it over to Drew and Dom.
Thank you so much for the great intro. All right, I will start sharing my screen and we will hop right into our presentation. Make sure I get the right screen. What am I doing? Yeah. Perfect, it looks like it's working. Hopefully everybody can see my screen now. All right, so this is going to be a presentation about using OnShape for your different Science Olympiad build events. So let's hop right into it. So the agenda for today's webinar, we're going to start by talking a little bit about what is OnShape and who uses OnShape, just to lay the groundwork of what this program is, how you can use it, and then how it's actually used worldwide in industry to make a huge number of products. Then we'll hop into what you actually want to know, which is how you can use OnShape for your Science Olympiad build events. Then we'll talk about getting started with OnShape. How can you actually learn the program? How can you become proficient with the program? And then how can you, actually master the program to make your different parts? And then we'll leave some time at the end for some Q&A. So a little bit about me. My name is Drew Bennett. I'm an education solutions engineer here on the PTC Education and OnShape team. So my background, went to the University of Maine, got my bachelor's in mechanical engineering, where I learned that I really loved CAD and just designing right about everything. My role on the team, I support education partnerships. That's where Science Olympiad falls in. I also do a lot of technical support for education audience. I also do a lot of technical content and curriculum development. So if you've looked at anything in the Learning Center, some different curriculum, there's a solid chance that I had a hand in developing that. My experience, I'm a certified OnShape professional. I was one of the national event supervisors for the Engineering CAD trial event last year, and I have over 10 years of experience working with a variety of different STEM activities in the K-12 space. I'll hand it over to Dom so he can introduce himself.
Yeah, nice to be talking with you all. My name is Domenico Damari. I'm a senior education applications engineer. My background is mechanical engineering. I definitely attribute a lot of that excitement and passion for engineering with Science Olympiad. I did Science Olympiad in middle school and high school, basically every single year. And I really loved all the building events, which is definitely how I got into and interested in engineering. Like Drew, I helped supervise the engineering CAD event. I've mentored teams once I've graduated from high school and college. I really loved going back and helping my local teams and really getting to give back to Science Olympiad. So it's really great that OnShape and PTC have this partnership, and we're working with Science Olympiad for all these great events. So back to you, Drew.
Thanks, Dom. All right, so what is OnShape? Whether you're familiar with OnShape, whether you're not familiar, just want to lay some of the groundwork here so everybody knows we're all on the same page. So two most important things about OnShape for all of you is that it is fully featured parametric CAD. And parametric CAD is the industry standard way that products are designed. So what it does is it allows you to create parts, combine those into assemblies, make your 2D drawings, and a whole lot more functionality. It's also cloud native, and that's really important because that is a key part of why we're able to do the bring your own device events for engineering CAD. So because the computation, all the heavy math, the geometry that makes OnShape work, is done on our servers, that saves your device's resources. So you don't need to have some very expensive laptop or desktop to run such a complex program. Some other great things about OnShape: it does have click-by-click revision history, so it's saving every single thing you do. You can't lose any progress, and you can always go back in time to see what you were working on previously. Great for working as a group. We have simultaneous live editing. This allows you to actually work on parts and assemblies at the same exact time and see what your partners are working on, and also provide live feedback. Does run on any device you've got: Windows, Mac, you've got your iPhone, you've got an Android device. We've got an app for it, or it can run on the browser of said device. Also, because OnShape updates every 3 weeks, you're always going to be running on the best performance, and you're always going to be getting a slew of new features. So you're always going to be running on the best form of OnShape that we have to offer. It's also nice just to point out that there are a ton of companies that have adopted OnShape since it went public around 2015. So of course, if you're familiar with the outdoors, you know K2. If you're a big audiophile, you probably have some Sonos products. If you like toys, Hasbro's a pretty household name, and there's probably a solid chance that you recognize Toyota. So this is just a small selection of different companies that have adopted OnShape to design one or many of their different product lines. So it's great to know that, as you learn these skills, you develop these skills to design your parts and assemblies for these build events. This is developing a skill that there are a lot of companies, they value these skills that you will be building. All right, let's talk about how you can actually use it for Science Olympiad. So in the education space, we recommend 2 different plans for the people that are in attendance tonight. So if you are a student, we recommend that you use the OnShape student plan. You can find it by going to onshape.com/edu and finding the sign up page there. It's a free plan that's ideal for individual students. You'll have access to the full suite of CAD and CAD management features, as well as access to the Learning Center. And of course, emphasis on it's free. Also free is the OnShape Educator Plan. This is what we recommend for coaches and for event supervisors. We'll go over more about why event supervisors need to be on the OnShape Educator Plan when we do our webinar about engineering CAD in November, but you want to make sure you're going to be using that plan. It's also important to note we do have a third offering for the education space. That's the OnShape Education Enterprise Plan. That's great if you're looking to implement OnShape, across a large implementation, like a large school or a college. It offers some great benefits that are very helpful when you're looking to do, large 1,000+ user implementations, which are pretty common at colleges and large high schools. So those are the 2 plans that you need to know about, and make sure you're on one of those 2. And like John alluded to, we are an official partner of Science Olympiad. And, the major things that we want to point out why we're all here today It's useful for a variety of your different build events. Of course, these are throwbacks to some events for last year, but we liked the models, so we wanted to throw them in there just to, inspire and show the different things that you can create in OnShape. And we are also the sponsor, writer, and help maintain the engineering CAD event, which is going to be a trial event, worldwide. It's going to be at the national event as well, at both the B and the C level this year, which is very exciting. Last year, if you did enter the engineering CAD event, it was just at the C level. So whole lot more people are going to be participating in the engineering CAD event. And again, we'll be having a future webinar about that sometime in November. So let's keep rolling. Let's actually take a dive, and we're going to end up looking at some different models about how you can use OnShape with your build events. So as the title was in Zoom, it was 4 ways OnShape can help you with your build events. So these are the 4 bullet points that we wanted to cover. So Dom and I did some brainstorming, and these are the major takeaways we had. So of course, you can use OnShape to design your completed assembly. If you want to get all the details covered in OnShape, you can do that. You can also design specific components for 3D printing. If your team has access to a 3D printer, this is a great way to make custom parts that you can then export, set up, and 3D print. Likewise, if your team has access to a laser cutter, OnShape is a great way to make parts for your laser cutter. It's very simple to design whatever you've got, export it, send it to your laser cutter, and just like that, you've got your custom components. A sneaky one that we actually think is also very worth talking about is how helpful OnShape can be to design fixtures and alignment methods for a variety of different events. We'll touch on that one with the last model that I'll be showing. Let's go on to the first set. So I'm very proud of this. I spent a lot of time on this. I think it's perfectly legal. Pretty sure I followed the rules. This is how you can model an electric vehicle in OnShape. So why would you want to do this? I wanted to do this because I wanted to be able to design and iterate on the ideal lightweight electric vehicle by adjusting a bunch of different parameters. So I wanted to check and make sure that I could adjust and perfect the chassis length, how wide it was. As you can see, it's pretty narrow. Not sure if that's for the best, but it's what I ended up going with. This would be my first prototype. I can also adjust the size of the wheels and the location and, other things like the width and how grippy they are by, what I'm going to be purchasing. Also can adjust my motor selection and ultimately the powertrain. Am I going to be using gears or belts? Am I direct driving the motors? How am I powering my wheels in the back? And then, of course, pretty importantly, you've got to figure out where and how you're mounting your electronics and making sure that your weight distribution is good. The battery holder's in the wrong spot. I don't think it's going to drive particularly straight. Not going to be the best event. And then, of course, this chassis was made to be 3D printed. So a lot of it was designed with FDM and 3D printing in mind. Let's actually go take a look at that model right now. Sweet. So here is my supposedly finished electric vehicle assembly. So as you can see, I've got all the different components in here, all the way down to the shafts and the bearings and things like that. So what's great about this is for the assembly, I was able to bring in components that I knew I was going to buy. So of course, I'm not making a motor. I did not feel like making the wheels. I'm not making any of the electronics. So all of that I was able to actually import. So you can see imports right there. OnShape is fully featured. So if you are able to go online and find something from like GrabCAD or one of your different vendor websites, it's very simple to import these parts so you can design around them. Once I've chosen a couple of my parts, we can actually go into my part studio here. So a little bit, I'm going to be going a little bit quickly, but you can see that in my OnShape document. So here, this is the OnShape document for the Science Olympic electric vehicle. I've got both the assembly in this tab. Then this tab just contains some of the parts. So this is actually where I made my sketches. I used my extrudes, revolved, all of those common parametric CAD features. This is where the magic happens. And I start from a series of very basic sketches. If I roll to here, you can see I started with just a layout sketch of where I wanted my wheels to be lengthwise, and then sort of what it was going to look like with the motor and the wheels from a very simplified top-down view. And of course, from there, you use a whole bunch of features to build up an actual model. So again, we're going to do a little bit of a simpler demo at the end. So I'm not going to get into, again, the how you're actually going to be doing this. This is more meant to show what you can accomplish by learning OnShape and then designing your own things. So of course, this are the different components for the chassis. Take a look at the electronics. I actually wanted to design the electronics mounts in a separate modeling environment. So I brought over the important parts, AKA that 5mm carbon fiber rod that's going to act as, the chassis spanner across the middle. And then I modeled up my battery holder, my switch that I can poke with the number 2 pencil, and then, the other mounts for my Arduino board, as well as the motor controller that's going to sit right below it. So that is a relatively quick overview of how you can, actually come together, bring all these different components, whether you're modeling yourself, whether you're actually going to be downloading it from somewhere online, and ultimately make a model. Now, of course, it does take a lot of skill. I've been doing this for a while, but you can make something that looks pretty close to this once you actually learn the basics of OnShape, if you're willing to put some time in, and we'll point out at the end where you should go in the Learning Center if you want to develop those skills. So I did also mention that this chassis was meant to be 3D printed. So I'll show you how that works. So it's very simple. If there's any of your models or parts that you're looking to 3D print, all you've got to do is right click on it and find the export button. So if I export, you'll see that I can set it to be either an STL or a 3MF. I started preferring 3MFs for my 3D prints. I feel like it ends up giving me better results. So I can set it to be a 3MF. Resolution of fine has always worked great for me. And then I can export it. And just like that, it will start downloading. So, yep, there you go. Boom, there's my downloads. So you can see just like that, you're able to download your different parts, and then you can send it off to whatever slicer you've got for your 3D printer of choice. Start printing some parts. Awesome. So that's an electric vehicle model and an example of how you can actually develop that. Let's go back to the PowerPoint. Scrambler. This one's pretty similar, but of course there's no actual electronics involved. This one is purely mechanical and the potential energy of the launching mechanism. That's the key to this event. So some major thoughts of how you can use OnShape for this event. Of course, you can use it to design your egg transport vehicle like we've done here. You can also use it to design your launching mechanism. We didn't quite have time to put together a good launching mechanism. We'll try and show that off at the end, maybe with a live demo. But definitely if you're looking to do a more complex launching mechanism, maybe something that uses elastics or some type of different conversion mechanism for the falling mass to your actual launch. It's a great way to design that up and do your tweaks to make sure that's actually going to work. Of course, it's also important that it actually fits in the size requirements. So if you model it in OnShape, you can very quickly measure it and know that it is going to fit in the starting box. And also, if you're looking to make some larger parts, especially if you're looking to do some woodworking to make said large launcher frame, it is really helpful that you could create manufacturing drawings in OnShape. So you could hand that to somebody so they know, they've got a 2x4, they need to cut it up to a couple different lengths to put it together. If you make some manufacturing drawings, it's very simple for them to know exactly what they need to make and check it off once they're done. Let's go take a look at the Scrambler model we put together for this webinar. Refresh real quick. Sweet. This is my Scrambler with a beautiful little egg on the front. It's not taped down. Tape is kind of hard to model, so I just didn't do that. But you can see this is a Scrambler model that uses a spring in the back, threaded rod, wing nut. If you've done events like this, you're pretty familiar with this style of build. So nothing super new to show off here, but it is important, again, of just to help visualize exactly what you could make with this. So it runs very similar to the electric vehicle, where this is the full assembly, where I brought in a variety of different components that were purchased. So you can see I brought in things like the nuts, the wing nut, the spring, were all imports, as well as the bushings there that the threaded rod rides on. So everything is very smooth. Those are grabbed from McMaster Car. So if you're familiar with buying different components from suppliers like McMaster Car, it is very easy, again, to import all of those and design around them. The actual part studio here, you can see everything was designed in one part studio and then organized into folders. So if I open that up, you can see, again, everything pretty much just boils down to a simple set of sketches and extrudes and some fillets in there just to make everything look good. But that is how you can make these variety of different models. And once again, this was made so that we could use aluminum extrusion as the main body with a couple simple holes, and then 3D print the end components. Now, like I said, we haven't modeled up a launching mechanism yet. Those are pretty complex, take a fair amount of thought. But what I can do is I can make a quick engineering drawing of this aluminum tube as an example of why a 2D drawing might be helpful. So when you're in your OnShape document, you can go into left, insert new tab. Let me drop in a drawing, and I will use, sure, the millimeter template works fine for me. Excellent. So as you can see, once you start up a drawing, you're going to end up in a drawing environment that if you've used other programs with drawings, you're very familiar with this. So let me go and I will grab the part I want to make a drawing of, and I will drop it in there. I'm actually going to set the scale to be, can I do 1:1, please? This is still going to be too long, but we'll get the point across. Actually, you know what? No, I am going to adjust that. Do sheet properties and 1:2. Sure, that's good enough. So as you can see, it is very simple to drop in parts. So again, if you wanted to, show how you want to make a cut list for your frame, for your launching mechanism, that's pretty simple. And then again, just like any other parametric CAD program, we do have a full drawing suite. So it's very simple to set up, dimensions on your drawing so you know exactly where everything is. And let me throw the length in there as well. Sweet. Now this is great because, if I've set up my engineering drawing so somebody can make it, let's say I want to print it off or get ready to go, I can export that as a PDF, download it, send it to the printer, ready for the manufacturing squad to make those components. So another great use of OnShape. Let's keep going. I'll go back to the PowerPoint and we will continue on with another event to talk about. Next, we have Robot Tour. Robot Tour is pretty cool, but it seems like a lot of teams like to use kits, but Robot Tour has a lot of customizability. There's a lot of different components you can buy to make your own custom robot that would be a little bit faster, a little bit smaller, a little bit more maneuverable. Maybe you've got a faster motor with a better encoder so you can better track where you're actually driving. So if that is of interest to you, it's probably worth designing your own robot for Robot Tour instead of just using a kit. So some things you could do in OnShape for that, you could design the frame of your robot. Actually, this frame right here, I made the top transparent so we could see the motors tucked inside. I thought it looked a little cooler, but you can design your own frame. Ensure the electronics fit, because that is always the part that has been the most difficult for me. I never leave enough room for the electronics and they end up getting like duct taped onto the side. So if you design it in OnShape, you can actually make sure they're going to fit from the start. And you can laser cut your frame components. We've already talked some about 3D printing. Thought it was important to also show off how easy it is to export parts if you have a laser cutter at your disposal. So let's take a look at my unfinished Robot Tour robot model. Sweet. So this is my Robot Tour robot model. And as you can see, I'm like a good amount of the way there. So this is the assembly where I've got my different motors. So these are, just some relatively basic TT motors. You can get these for a couple bucks online, but they've got an encoder in the back. So I can actually track how far each wheel has driven. It's pretty critical for this event. Then I've also got my motor driver up here. I've got my Arduino Uno Rev 3, I believe, right here. And I've also got my relatively large and relatively generic battery holder up here. So pretty sure that's about everything I would need for Robot Tour. I probably forgot the dowel in front as well. You need a marker up there. This is why you need to model it so you can keep track of all these details and provide feedback as people are putting it together. But this is what, a somewhat finished Robot Tour model can look like. If we actually go take a look at the chassis, you can see here that it is intended, if I hide the battery and the wheel, it's intended to be laser cut and then held together with some finger joints as well as some standoffs. We'll just run some bolts down through into some relatively cheap and common standoffs to make a very robust and very cheap and very quick to make Robot Tour chassis. What's nice about this, of course, is since it's all parametric, if I need to, I can see that I've got my length defined here. So I'm going to bump it up to 175. We can see that it is going to think about it and then it's going to update. And also Control Z that back so you can see that it did update. But what's nice is for laser cutting, a couple different things I'll show off. This is a little bit deep, but this is a great thing about OnShape. And if your team is looking to become proficient in OnShape, this is something you're going to want to look into. OnShape does allow users to develop their own features. So you're not just limited to extrude and revolve and sweep and things that you can find along the top toolbar. The OnShape community has access to the actual code behind these features, and you can develop your own. And a lot of people develop their own features and then share them out. So one that I like to use is called Laser Joint. And what it actually does is it creates this type of automatic finger joint between the parts. So, if you're interested in this, you can look up Laser Joint OnShape. There's a whole bunch of resources online about how you can become proficient in designing for laser style construction in OnShape. I really like using it. It saves a ton of time because otherwise drawing this out is pretty time consuming. So there's a lot of different ways that you can automate and save time by using feature scripts in OnShape. And now that I've got it all set up, let's say I want to take this part and I want to send it off to my laser cutter. All you need to do on any flat part you've got, you can click on the face so it turns this selected orange. A right click opens up the menu, export as DXF DWG. I'm going to export it as a DXF and I could, name it motor mount. And when I export that, the DXF that downloads, that's a type of thing that you can bring into your laser cutting post processor, whether it's Lightburn or, Corel Draw or, AutoCAD 2D, whatever you use to communicate with your laser cutter, you can open that DXF, you can set your settings, Control P, send it off to the laser cutter, zap out your part real quick. So if you're looking to make custom chassis, this could also be relevant for electric vehicle, but I definitely think the size and constraints of robot tour make it a pretty good event to actually laser cut different components. So you can make a lightweight, very customized chassis to be as small as possible. So you can maneuver around those 2x4s and go through each gate as quickly as possible. All right. Back to the presentation. Let's take a look at one more event, and that is going to be tower. This is a little bit interesting because it's not particularly intuitive to design your entire tower out of balsa wood in OnShape. It seems like it's probably better to just make it by hand and hope for the best, or maybe do some simple simulations in something like an ANSYS software, so you know roughly how much force it can handle. But as Dom and I were talking about this, we did think it'd be really helpful to design your fixtures to hold parts during assembly, because otherwise keeping everything in place to glue it is pretty tricky. And again, if you make your fixtures and you check all your designs, you know that it's going to meet the rules before you make it, and have a bad day when you figure out it's over height or it does not fit in the required base. So let's take a look at a tower model designed in OnShape. Cool. So as you can see, Dom spent a good amount of time and he sketched out, he's got our rules template here, which is super helpful. So the very first thing he did was create a sketch with the correct dimensions so we know where our footprint for the tower needs to be. This is a great visualization tool. Make sure that, anything that we're imagining in OnShape is actually going to be legal. So once we have that sketch in place, he spent some time putting together some different balsa wood triangles so that we can create our 3 points of contact. And he set up some time, he built this truss work. But like I said, actually gluing this all together and making sure that it is, equal and not going to be a little bit lopsided is pretty tricky. So it'd be really helpful if we could design and 3D print a fixture that could actually hold all the wood in place for us, make it much easier to line up. So this is an example, probably not perfectly 3D printable as it sits right now, but the general concept applies that using OnShape, it's very simple to design 3D printed jigs that you can print out and use to actually align or hold, or, you could tape the wood onto these pieces and then put your glue or epoxy on there to run your spans across and line it up. So, I do think this is really helpful if you want to, make sure that you're actually going to build it correctly the first time. Spend some time thinking about, are there ways, doesn't necessarily need to be this big. This is a pretty huge jig. We can actually do a quick measurement and see that it's 50 centimeters tall. So it's pretty big, hence why it's broken into two. So it can actually fit in our 3D printer. But, even smaller ones that could just allow you to get the correct angle between something like this. So, it would bump up against that face and allow you to align these different cross members, whether it be a big jig or a small jig. Anything that can help you line it up is going to be really helpful. So if you've got access to a 3D printer, highly recommend taking some time to think about, is there a way you can use OnShape in your 3D printer to make your balsa wood construction a lot easier? That's a different way that you can use OnShape for the tower event. All right, we'll go back to the PowerPoint. So with all that covered, those are 4 different events that we think OnShape definitely applies to. Of course, you can get creative and use it for a whole lot of other of the build events, but those are definitely some highlights that we wanted to cover. And now that I've given some different inspirations, some different ideas, I'll hand it over to Dom so he can talk about how you can actually get started learning OnShape so you can design some of the crazy stuff that I just showed off there.
Cool. Thanks, Drew. quickly, let's talk a little bit about questions and answers. I see them in the chat right in the Q&A function. We'll get back to those momentarily. I'm back.
How you doing, Dom?
That was weird. Zoom just crashed. We'll try
We
this
love
again.
Zoom.
We'll try one more time. Otherwise, Drew, you're going to keep going. I know you got it.
Oh boy.
Cool. So questions and answers, we're seeing those. We're going to answer those in a minute. A couple of them I think we're going to talk about coming up here in a second. So first things first, what do you need to do to get started with OnShape? You're going to need to sign up. You can sign up at onshape.com/edu. Simple form you fill out. You're going to fill that out with your name, your email. If you're a student or an educator, students will automatically get that student account. If you sign up as an educator, you'll get that educator account. Really straightforward. A couple questions in the chat were about the age you needed to be to sign up for an account. If you're a student over 13, you can just sign up on your own. For students under 13, as long as you have the consent of your parent or guardian or a teacher for education purposes, you'll be able, your students under 13 are able to sign up with that consent from a parent, guardian, or teacher that is using it for the student's education. So anybody, Division B, Division C, can just get in here at onshape.com/edu and sign up. Sweet. So what do you do once you've signed up? Well, you're going to need to learn a little bit about OnShape. And the great resource we have for you is the OnShape Learning Center. The Learning Center, once you've signed into OnShape, you can click a button at the top right. You'll be brought right to the Learning Center. You can also go to learn.onshape.com. And this is where you're going to find a ton of resources. A lot of these resources are self-paced learning. So as a student or an educator, you can just go through, click through some step-by-step examples, short videos, 3 to 5 minutes that talk about a concept. And then they have exercises that actually take you through designing, making something, applying those concepts with a self-check. So really easy to follow along for both educators and students. There are also resources directly for educators that we hear checks, quizzes, step-by-step instructions, all built right in and ready to go. The last thing I want to talk about in the Learning Center is actually certification. So like Drew mentioned at the very beginning, this is a professional tool. It's really approachable for students and educators to get in because it's cloud-based and easy to sign up and a lot of really easy features to use, but it is professional and you can sign up, get a certification, take an exam, and actually take and get an industry recognized credential. So that's open for educators if they want to sign up and get that certification, as well as students. A couple great resources in the Learning Center specifically that I recommend are CAD Basics and OnShape Fundamentals. CAD Basics is meant for somebody that's never touched CAD before, so it really introduces you to the basics, like it says in the name. There's 5 courses, very straightforward, starts with the assumption that you haven't used CAD. OnShape Fundamentals is really meant for somebody with experience with other professional CAD tools out there. So there are definitely some educators out there that have used other tools, some students even now. It's been really great to see they've got a lot of different experience in different tools. So if that's the case, you can take OnShape Fundamentals. It kind of glosses over some of the basics of CADing, but really gets you right into OnShape, explains the differences and how to really take advantage of OnShape.
Dom, can you check your mic? You got awful quiet on us all of a sudden.
I don't know. That's weird.
Thank you for bringing that up in the chat.
How about now?
That is a little bit loud, actually.
Uh-oh. Now we're too loud?
Let's find a middle ground there.
We'll find a middle ground. You can
Down
just yell at me, Drew, if it happens again.
Down a little bit.
Cool. So the Learning Center, great resources. Let's hop into the Learning Center and into OnShape and explain a couple of these basics and where things are. So here we are in OnShape again. Mine's a white screen instead of black. I know Drew likes dark mode, which is new to OnShape. I'm getting used to it. I still like light mode better. But we can go over here to the top right when you're signed in, go to that Learning Center, bring you right to it. And in the Learning Center, we're going to see a couple of those options I talked about. Self-paced learning is where some of these courses are. You can go ahead, click on those learning pathways. There's a couple of them here. CAD Basics is that one I mentioned a second ago, and OnShape Fundamentals. So all you have to do is click on them, and then you can get started. Very straightforward. Like I mentioned, couple videos here you watch, and then you can go through some of this self-check. So really straightforward. Definitely what I recommend if you haven't used OnShape before, if you haven't used CAD, come here to the Learning Center, get all those resources you need. Cool. Let's go back to OnShape, and I'm going to quickly show off some of the basic features and basic things that you need to get started. So first, we'll need to create something to get started. So I can click that Create button at the top left. Like Drew was showing off, OnShape organizes things into this concept of a document. So I'm going to open up this document. I'm just going to call this demo for SO. I'll go ahead and create it. And Drew was showing some really great examples that were pretty much fully fleshed out. This is what it's going to look like the first time you or your students get into OnShape. It's going to be a little less.
Dom, check your audio.
I don't know what could be happening. I haven't even moved. Let's see. So first thing you're going to see is a part studio. And this is where we're going to be modeling parts. Core concept of OnShape, you have a toolbar at the top and a feature list on the left. The features are the things that are creating your geometry. And one of the core things you're going to need to start with is a sketch. So a sketch is just going to be 2D. We need to tell it what we're going to sketch on. So we're going to sketch here on the top plane. We can look at that top plane from the top as you would expect. And now we have a whole bunch of these different sketch tools in the toolbar that are going to allow us to create that 2D geometry that we need to eventually make 3D. So I'm going to make a pulley bracket here. Pretty easy. I'm going to start with a rectangle. I can use a dimension tool here to add the actual dimensions of what this is going to be. So maybe we'll make it 3 by 1 inches. That's going to be the bottom of the bracket. Core concept here in OnShape. This is parametric feature-based CAD. And what that means is we need to define all the parameters of our design. In this case, it's going to be the dimensions, right? It's going to be how wide is it? How thick is it? So once you've got this rectangle here, that's a sketch. As you can see, it's 2D. If I look at it from the side, there's nothing there yet. How do we turn this 3D? That's where the rest of these features come into play. So I'm going to go ahead and use this extrude feature. I'm going to click on. Whoop, I think I'm back. Looks like I dropped off there for a second. So I'm going to make this a 1/4 inch thick. And now I've actually got something 3D. In this case, it's a pretty straightforward rectangle box thingy. So we're going to keep going here, add some more features. I can use that sketch tool again. This time I'm going to sketch on the top of this, and I'm going to keep going. I'm going to add some more rectangles here. I'm going to put one over here. I can use a line to go ahead and dimension these to the center. There's all sorts of different tools here that as you get used to using OnShape, as you take those courses, you'll understand a little bit more about what each of these different types of geometric features or constraints actually mean. All these are important to use to make sure you're defining the actual dimensions of what you're designing. That's, engineering. You need to go ahead and put dimensions in. Otherwise, you're kind of just guessing. And even if I'm guessing at these dimensions right now, having them defined lets me go back, iterate on my design, make things larger, make things smaller, change the way things fit together once I've actually manufactured it and tested it. So I'm going to keep going here quickly. We're going to extrude those. Some other features that you often run into is the fillet tool, which lets you round the corners of parts. So I can go ahead and round some of these top edges, maybe the bottom of the corners of the brackets here. Get those all rounded, starting to look more like a bracket, I think. Next thing we'll probably want to do is add some holes so we can attach this to the actual frame that this might go on. So I'll draw something with 2 points, and then I can use the hole wizard here to go ahead and choose those points. I can change the different size of the hole based on drill sizes or whatever other standard you want to go with. You can also just put in any number you want, but maybe we want a clearance hole for something like a 1/4 inch bolt. We can go ahead and grab that. We've got holes there, and we'll probably also want to add one here for a bolt to go through so that we can attach our pulley. So in this case, I'll make it a little bit smaller, and we can extrude that blindly through everything, and we can change that to remove. So that's really at the core of what you're doing with OnShape. You're taking these 2D sketches, you're using some of these feature tools to create geometry, to remove geometry, and that's how you're going to build up these parts. So I created one part here, but I can keep going. Maybe we need to add the actual round pulley part in here. So I can go in and start sketching on this other surface. And I can go ahead and create. I'm going to make this a little bit differently. I'm going to use another feature here in OnShape called the revolve feature. So instead of extruding this part, I'm actually going to revolve it and create basically a circle. So you're going to see what this looks like here, a disc rather, in a second. I'm going to, maybe we need a little space here for the rope to cut into it and hold on. And then I can, instead of using extrude like we used before, I can use revolve. And so this is actually going to rotate this sketch around an axis. So I can choose the sketch, I can choose the revolve point here. I can make this a new part. As you can see, this part's a little bit big. I can go back to sketch 5 and actually put in some of these dimensions here. We'll make it much smaller, and that should help it fit in here. There we go. And now you've got a disc through there. Cool. Now we've got 2 parts. What are we going to do with 2 parts? We're going to want to assemble them together. And that's where the assembly comes in. Before I do that, though, we did have another question about sharing and collaboration in OnShape. Does it work like Google Docs? Well, it basically does. So I'm going to click on this share button at the top right. I'm going to add in Drew. And I'm going to go ahead and give him a choice of permissions here. I can let him edit, can let him copy, I can let him link. In this case, he just needs to edit, and I can go ahead and share it with Drew. And what this is going to do is work just like Google Docs. So Drew is going to get an email saying he got added. In his OnShape, he's now going to see this document. And you can actually see here, Drew's already hopped into the document. You get a little notification at the top right that there's somebody else in here. You can have 1, 2, 3, 4, 5, as many people as you want in a document at the same time collaborating. what's really cool is you can actually double click on the other individual's logo. So I can double click on Drew, and I'm now actually following Drew. So I swear my hands are up here. I'm not doing anything. I'm actually following along with what Drew is up to. And this is all in real time. So Drew, why don't you start working on a frame? Let's imagine that this is going to be for Scrambler, and we're going to need a frame to create a weight, and we're going to drop something. It's going to go around that pulley. So Drew's going to start editing here, and I'm going to keep going with talking a little bit about assembly. We'll check in a little bit of how Drew is doing. So I'm going to hop into a different tab at the bottom here. This is where we can see this first start part studio that I created. We'll call that pulley. And Drew is working on the launching frame in a separate part studio tab. And I'm going to actually go ahead and click on the assembly tab. And here is where I'm going to create the assembly of the pulley, where things are going to be able to rotate. So I'm going to click the insert button at the top left. This is going to let me see all the different parts that I've designed in this document. So I'm going to bring in part 1 and part 2. Now I can see both of them, but if I left click and hold and drag them away, they're not connected in any way. And that's what we're going to add here, is these connections between components, where we're going to want things to move.
Dom, can you turn up your audio a little bit?
What about now? So let's keep going. I'm going to fix my first component. That's going to lock it in place. Now it can't move around. And then what I can do is use a mate to define the relationships between these two components. So fastened mate, that's going to lock the components together. A pulley obviously rotates, so we might actually want the revolute mate. This allows rotation. So I'm going to click on that mate, and now I'm going to start using what are called mate connectors. That's this little icon here in the center that has a X, Y, and Z coordinate system. It's basically a point. And basically what you're going to do is say, I want this point on this part connected to this point on this other part. So I'm going to connect the center of this right there to the center of the bracket over here. And so a couple things we might want to do. We might want to offset this. We want to move it maybe 1/2 inch to the center. Oh, other way, sorry. There we go. And now we've got that locked here in the center, and it can actually rotate, which unfortunately is kind of hard to see because there's nothing on the pulley. Immediately those changes. Oh, am I back?
Maybe.
The internet's actually back. Oh, it's thinking. Am I back?
We can hear you.
Okay, cool. Sweet. Oops. There we go. So I can make some quick changes to this model here. Maybe I'm going to sketch something on the side of this so that we're going to be able to see whether or not it's rotating or not. So we can go ahead and remove that. And if I go back to that assembly, the part's going to have updated. And now you can actually see it's rotating, which is a little bit helpful. So in that time that I've been putting this together, let's check out what Drew's been doing. Okay, so Drew's been a little bit more productive than I have. He's actually got this whole frame put together, which is awesome to see. Again, he's done this in real time, shared completely different places. Really just works like Google Docs or Google Sheets, where you've got people all collaborating in real time with each other. Then you're able to share this with anybody, and they're able to actually just go ahead and see what's been going on. Another nice feature is actually the comment functionality. So on the left over here, there's this comment button. This allows you to, like Google Docs, actually add comments. So maybe I can say something like, Drew, this looks great. Is it tall enough? Question mark. I can tag actually the geometry. So maybe I'm referencing this length here. I can actually click on that. I can attach something if I wanted. I can mark it up. So this actually goes into an editor here, and I can, point to something or draw around, whatever you need to do to get your point across. And all of that is going to be saved in this comment. You can actually tag people if they want to show up here, but then you go ahead, click add, and that's now in this document. Drew can take a look at it. He can reply to it if he's got different ideas. Really easy inside of OnShape to just be able to share those ideas back and forth via the comment functionality. Cool. Couple other quick things I didn't quite get to here. In that insert feature, there's actually a whole set of standard content. So these are kind of your standard ISO, ANSI inch, bolts and screws, nuts, all those kinds of standard machinery components. They're going to be already built in, and you can just use those in OnShape. So I can go ahead and insert this component if I wanted to. Really easy to just go ahead and add those standard components that you might be buying at a hardware store or from a supplier. Sweet. Well, let's hop back into the PowerPoint. One more thing we wanted to quickly talk about is our future webinar, which is going to be solely focused on the engineering CAD trial event. So if you're interested, you can join us on November 19th to learn more about engineering CAD. This is a great event where you're really learning applicable skills for the engineering field, which a lot of the time you're dealing with drawings. You have to create drawings for manufacturers. In this case, we're going to give you a drawing, and then you're going to have to replicate that in OnShape and be judged on how close and accurate you are to that drawing. It's a team event, so we're really using those collaboration tools in OnShape. Two students are going to be able to work in real time with each other at the event and go ahead and make those drawings, combine them together, and create an assembly. So at this webinar, we'll be talking about some of the materials we've created to help you as students or help you as educators run and learn this event. Also, if you're thinking about being an event supervisor, we have some useful tips and tricks that we'll want to share with you. Cool. That's all we have for the webinar, but we've definitely gotten some questions. So I think it's time to answer some of those, right, Drew?
Yep, definitely. So I believe a good number of them have been answered already. So we provided text-based answers to you. So hopefully that was what you were looking for. There was a good one. I'm just going to ask myself because, Dom, frankly, I do not trust your audio, buddy. You've been all over the place. Appreciate you, though. There was a question asked, can students use the program on their school Chromebooks? And very important, the answer is yes. So what you need for OnShape is just a laptop or desktop or any device that can connect to the internet and is connected to the internet. So once you have a stable internet connection, you can either download the OnShape app if you're doing it on your phone. On the Chromebook, you will just open the Chrome browser, go to cad.onshape.com. You will sign in once you've got your account, and you'll be able to access that modeling environment where Dom just showed off that he was making parts and assemblies. We were collaborating live. So that is very doable on a Chromebook. We had students competing last year in the engineering CAD event. They brought Chromebooks. That works great. We also have hundreds of schools all around the globe, probably well more than hundreds, many hundreds, that are using Chromebooks as their primary devices when they're teaching CAD in the classroom. So long way to say yes. Actually, another great question. Are student educators' accounts data public or private? So that's an important thing about when you are signing up. Make sure that you do not sign up for the hobbyist account. Make sure you are signing up as a student or educator, because if you sign up as a student or an educator, all of your data is private. There you go. So, yep, all of your data is private. Got nothing to worry about. OnShape also does take security extremely seriously. We do a lot on our AWS backend to be very, very secure with every bit of data that we collect, which frankly is not that much. So, yep. Awesome.
All right. Thank you very much, guys. We're like right up to time. So just want to say thank you to Dom and Drew, if you guys would throw it in the chat. And they talked about they're going to do another one specifically focusing on engineering CAD in about a month, right? I think on November 19th, the target date. So I would encourage you to come and check that one out, especially since that's one of the events we are really encouraging tournaments to include as a trial event. And it will definitely be for anyone on here that has national ambitions. I can tell you that engineering CAD, both Division B and Division C, will be showing up at nationals. So that's something to think about. Before that, we had a couple other webinars happen in November. So if you haven't, check out the workshop page on the Science Olympiad website. You'll see links to register. Also follow at Science Olympiad Official on Instagram. That's where we're posting all the things about workshops and upcoming opportunities. And last but not least, check out the newsletter. And if you haven't signed up for the newsletter yet, you can find a newsletter sign up on the main Science Olympiad website. So at this point, thank you everybody for hanging out. Thank you, gentlemen. A fantastic presentation. Love seeing it, and actually gave me a whole bunch of new things to think about.
Awesome.
So you guys have a wonderful evening. To all the students, coaches, people out there, I hope to run into you guys at a tournament. Have a great night, and we'll see you later.
Have a good one.